the final test. A grade 10 environmental science class has spent the last 3 weeks studying climate systems. They have studied tipping points, they have studied feedback loops, they have built a cross comparison chart of 3 case studies: the melting Arctic permafrost, the bleaching of the Great Barrier Reef, the accelerated retreat of Himalayan glaciers. They have generalized. The class has produced a sentence that sits on the wall. When a feedback loop crosses a threshold, the system reaches a tipping point and cannot return to its previous state without intervention from outside the system. The teacher walks in on a Monday morning. She does not review the sentence. She does not test it directly. Instead, she puts an image on the board: the Amazon rainforest, photographed from above by satellite. There are visible swaths of cleared land. There are roads cutting through the canopy. There is smoke rising from several locations. The teacher says, predict what happens if deforestation in the Amazon crosses the threshold we identified for tipping points. Use your generalization. Defend your prediction with at least 2 pieces of evidence from your case studies. The room is silent for a long moment. The students look at the image. They look at the wall where the sentence lives. They look back at the image. Then a hand goes up. A student says, the Amazon is currently a carbon sink. If enough trees are removed, it will become a carbon source instead. That is a feedback loop. Once it flips, the loop will accelerate the very thing that caused it. That is a tipping point. The system will not return to a rainforest without massive replanting that may not even work because the soil will have degraded. The teacher says nothing for a moment. Then she says, tell me how that connects to the permafrost case. Another student picks up. The permafrost holds methane. When it thaws, the methane is released. The methane causes more warming. The warming melts more permafrost. The Amazon is the same shape of system. It holds carbon. When trees burn, carbon is released. The carbon causes warming. The warming dries the forest. The forest burns more. Same feedback, same tipping point. This is transfer. This is the moment the lesson stops being a lesson and starts being a tool. The students have not been told the answer. They have not been given the Amazon as a case study. They are applying a generalization they built from 3 other cases to a 4th case they have not formally studied. The sentence travels. The concept is doing work. This is the 6th phase of a concept-based inquiry lesson. This is the moment of truth. What transfer means? Transfer is the application of a generalization to a situation the student has not seen in class. It is the test of whether the concept the student built is real. Either the rule works on the new case or it does not. Either the student truly understood or the student was guessing well enough to fool a quiz. There is a way of thinking about this that I want you to hold in mind. Everything before the transfer phase is preparation. The provocation, the concept formation, the investigation, the organization, the generalization. All of these phases build up to one moment. The moment the student takes the rule out of the classroom and applies it somewhere new. If the rule works, the concept is real. If the rule does not work, the concept is fragile. The lesson must be revisited. This is why transfer is the final test. It is the only assessment that actually measures conceptual understanding. Every other form of assessment can be gamed. Multiple choice can be guessed. Definition, recall can be memorized the night before. Even an explanation of a case study can be a regurgitation of class discussion. Transfer cannot be faked. The student either applies the rule or does not. The student either explains the new case using the concept or hand waves. The teacher, reading the student's response, can tell the difference instantly. There is something unmistakable about the sound of conceptual thinking versus the sound of guessing. A good transfer task takes 10 minutes to design and 10 minutes for the student to complete. The information it gives you is more useful than any unit test. You learn in those 10 minutes whether your unit succeeded. 3 kinds of transfer. It is useful to distinguish 3 kinds of transfer. Each is harder than the last. Each tests something different about the student's grasp. The first kind is near transfer. Near transfer is applying the rule to a case that is similar to the cases studied but new. The grade 8 revolutions class generalized from the American, French, and Arab Spring. Near transfer would be applying that generalization to the Russian Revolution. Different historical period, different geography, same kind of event. Near transfer asks, does your rule work for another instance of the same kind of phenomenon? Near transfer is the easiest kind to design. It is also the easiest for students to succeed at. If the lesson worked at all, near transfer should work. If a student cannot manage near transfer, the concept is not real for them. The unit needs to be revisited, reteach, reorganize, regeneralize. The second kind is far transfer. Far transfer is applying the rule across domains. The same concept reappears in a completely different subject or context. The grade 8 revolutions class generalized about tipping points in political systems. Far transfer would be applying tipping point logic to an ecosystem on the edge of collapse, or to a social movement gaining momentum, or to a personal habit forming after many small repetitions. The structure of the concept is the same. The surface is completely different. Far transfer is the gold standard. It is what separates the student who has memorized a unit from the student who has built a real conceptual tool. Far transfer is hard. Many students never reach it. The ones who do have something the others do not have. They have the underlying structure of the concept, abstracted from any particular case. They can spot the same shape of system across domains. They are doing something close to expert thinking. The third kind is action transfer. Action transfer is applying the rule to one's own life or to action in the world. A grade 4 class that studied interdependence designs a school waste reduction plan. A grade 7 class that studied persuasive writing produces a campaign letter to a local council. A diploma talk class that studied bias designs a personal practice for recognizing bias in their own thinking. Action transfer turns the concept from a tool of analysis into a tool of life. The concept is not just for the test. The concept is for next Tuesday. The concept is for the decision the student makes when they get home. Action transfer is the rarest in school. We almost never design for it. We finish a unit, give a quiz, move to the next unit. The student never applies the concept to a real situation. The concept becomes school knowledge instead of life knowledge. That is a tragedy of the school day. It is also mostly our fault. We did not design the action task. We did not give the student a chance to use the concept. We taught a unit and stopped. 3 kinds: near, far, action. A truly excellent unit includes some of each. Why most assessments miss this? A hard truth. Most assessments in most schools test only near transfer, often less. Often, the test simply asks students to recall what was taught. A unit on the French Revolution ends with a test that asks, list 3 causes of the French Revolution. That is recall, not even near transfer. The student does not have to think. The student just has to retrieve. The student who studied the night before can pass that test without ever understanding what a revolution is. A unit on photosynthesis ends with a worksheet labeling parts of a leaf. That is recall. The student does not have to apply anything. The student just has to know which arrow points to the stomata. A unit on persuasive writing ends with an essay on a topic the student already practiced. That is, at best, application of a known structure to a familiar topic. The student is not stretching. The student is repeating. None of these tests would reveal whether the student can apply the concept to a new situation. None of them would distinguish between a student who built the concept and a student who memorized the unit. They are all the same blunt instrument. They test memory. They do not test transfer. I'm not saying recall is worthless. It has a place. Students need to know facts. But if every assessment is a recall test, the message to students is that learning is memorization. The lesson becomes the unit and not the world. The student becomes a vessel and not a thinker. The school becomes a sorter and not an educator. The fix is straightforward. Design assessments that include transfer, real transfer, to situations students have never seen. The transfer task should appear in every unit, not at the end of the year, inside the unit itself. The GRASPS framework. There is a useful framework for designing transfer tasks that I want to share. It comes from the Understanding by Design tradition. The acronym is GRASPS. G stands for goal. What is the student trying to achieve? The goal should be a real-world purpose, not complete a worksheet. Something like convince the school board to add bike racks, or design a sustainable lunch menu, or predict the impact of a proposed law on a population. R stands for role. What role does the student play? Are they an engineer, an economist, a journalist, a scientist, a civic activist? The role gives the student a perspective from which to apply the concept. It also makes the task feel real. S stands for audience. Who will receive the work? A real audience makes the work feel meaningful. The school board, a community organization, a younger class, the town council, parents. Even a fictional audience, if specified clearly, focuses the student's writing or thinking. S stands for situation. What is the context? What is happening in the world that the task addresses? The situation grounds the task in real circumstances. It also signals the constraints the student must operate within. P stands for product. What will the student produce? A report, a presentation, a model, a campaign, a piece of writing, a design? The product is the artifact through which the student demonstrates their thinking. S stands for standards. What are the criteria by which the product will be judged? Not just superficial criteria like length or formatting. Conceptual criteria. Did the student apply the generalization? Did they cite evidence from the cases studied? Did they extend the concept to the new situation? GRASPS gives you a framework for designing transfer tasks that do real work. Let me show you one for the grade 10 climate class we opened the chapter with. Goal: assess the tipping point risk for the Amazon rainforest. Role: junior scientist preparing a briefing for a regional government. Audience: the environment minister of an Amazon basin country. Situation: the country is considering whether to ease deforestation regulations to support short-term economic growth. Product: a 2-page briefing memo summarizing the tipping point risk, the supporting evidence from at least 2 other case studies, and a clear recommendation. Standards: the memo must apply the class generalization about tipping points. It must cite at least 2 of the case studies from class. It must distinguish near certain risks from speculative risks. It must include a 1-paragraph counter-argument and rebuttal. That task tests transfer. The student cannot pass it by recalling facts. The student must apply the concept of tipping points to a new system. The student must compare across cases. The student must produce a piece of work that has a real-world structure. The task is far more demanding than any unit quiz, and it teaches more about what the student knows. GRASPS works in every subject. A grade 4 class on fractions could use GRASPS for design a fair way to share 5 chocolate bars among 8 children at your sister's birthday party. Write the recipe and the maths. A grade 7 history class could use GRASPS for write a journalist's article from the perspective of a particular witness to a particular event. Use your understanding of perspective to shape what is included and what is left out. A diploma philosophy class could use GRASPS for analyze a current news event using the framework of ethics we have built. Submit your analysis to a relevant local publication. The frame is generic. The substance is yours. Worked transfer examples. I want to walk through 4 transfer examples in detail. One from primary maths, one from middle school science, one from high school humanities, one from diploma, so you can hear what good transfer sounds like. The first. A grade 4 mathematics class has worked on fair sharing. They have generalized. The sentence on the wall reads, a fair share gives every person the same amount of the same thing, even if it requires dividing the thing into smaller, equal pieces. The transfer task. The teacher reads aloud. Your family is going out for pizza. You are 5 children and 3 adults. 3 pizzas have been ordered. The adults agree they will each take a slightly larger share than the children. But each child must get the same as every other child, and each adult must get the same as every other adult. There are 8 slices per pizza. Show me how you would divide the pizzas. Defend your answer using our class definition of fair share. That task tests near transfer in maths. The student must apply the rule. There are multiple defensible answers. The student must show their thinking. The teacher learns whether the student can take the rule out of the chocolate bar context and into the pizza context. If the student succeeds, the rule is real for them. If they fail, the rule needs another sort. The second, a grade 8 science class has worked on density. They have generalized. The sentence on the wall reads, an object floats when its density is less than the density of the fluid around it, and sinks when its density is greater. Whether something floats depends on the relationship between object and fluid, not on size or weight alone. The transfer task. The teacher hands out 3 short scenarios. Scenario 1, a small watermelon is dropped into fresh water, then dropped into the Dead Sea, which has a density of 1.24 grams per milliliter. Predict and explain. Scenario 2, a steel ship is loaded with cargo until it sits much lower in the water. At what point will it sink? Explain using the words average density. Scenario 3, an ice cube floats in water. The same ice cube is placed in pure ethanol, which has a density of 0.79. What happens? Explain. That task tests near transfer that begins to lean toward far transfer. 3 different fluid systems. The student must apply the same rule. The watermelon case introduces a non-water fluid. The ship case introduces the idea of average density. The ethanol case challenges the student's intuition because the rule predicts something counterintuitive. The ice that floats in water sinks in ethanol. The student must accept the rule over the intuition. This is hard. The student who succeeds is doing real conceptual work. The third, a diploma history class has worked on revolution. They have generalized. The sentence on the wall reads, revolutions occur when an existing order loses legitimacy, opposition gains organization, and a triggering event mobilizes action. Their outcomes depend on what replaces the old order, not merely on what was overthrown. The transfer task. The teacher hands out a 1-page briefing. It describes a hypothetical country in 2026. The country has been ruled by the same family for 41 years. Inflation hit 78% last year. Youth unemployment is 44%. 3 weeks ago, security forces shot a young protester. Video of the shooting reached 14 million viewers in 3 days. A coalition of trade unions, students, and exiled opposition politicians has called for a national strike. The president has threatened to crush any protests. The student must analyze the country using the class generalization. Is the country tipping into revolution? What conditions are present? What conditions are missing? If it tips, what will determine whether it succeeds? That task tests near transfer in history. The country is fictional. The conditions are described in terms the class has already studied. The student must apply the rule and explain. A student who succeeds will write something like, Country X is showing all three preconditions. The regime has lost legitimacy. Opposition is gaining organization. The shooting is a credible trigger. So yes, it is tipping. Whether it succeeds depends on whether the opposition has a coherent vision for the replacement order, not just a coalition against the regime. That answer is the lesson made real. The fourth, a diploma theory of knowledge class has worked on the concept of knowledge claims and the difference between knowledge claims and opinion claims. They have generalized. The sentence on the wall reads something like, a knowledge claim asserts something about the world that can, in principle, be tested against evidence. An opinion claim asserts something about preference, taste, or evaluation, which depends on the judging subject. The transfer task. The teacher hands out a list of 10 headlines from current news sources. Each headline contains a mix of knowledge claims and opinion claims. The student must identify which type each claim is, and for each knowledge claim, propose how it could in principle be tested. That task tests transfer at a meta level. The student is applying a framework of analysis to real-world media. The student is doing what philosophers do for a living. The TOK class is doing TOK, not memorizing TOK. 4 transfer tasks, 4 subjects, 4 grades, all sharing the same structure. The student takes a rule the class built and applies it to a situation the class did not study. The task reveals whether the rule is real. The task teaches the student that the rule is useful. The task closes the loop. Transfer should happen inside the unit. There is a move that distinguishes good CBI units from great ones. Great units transfer inside the unit. Not only at the end. It is common to think of transfer as the final task. Build the concept across 3 weeks. Then transfer at the end. This is better than nothing, but it is not as powerful as transferring throughout. Every concept needs an immediate transfer test. Within a day, within the same lesson if possible. As soon as the class has articulated a generalization, the teacher should have a new case ready. Try the rule on this. The students apply. They discover that the rule holds, or they discover that the rule needs refinement. Either way, the rule gets stronger. The concept becomes more portable. In the Grade 4 Ecosystems class, the moment the class generalized about interdependence, the teacher asked, predict what happens if all the bees disappear from a meadow. The students applied the rule. They predicted cascades. The next day, the teacher asked the same question about a different ecosystem, a coral reef, then a city park. Each repetition stretched the rule further. Each repetition strengthened the concept. In the Grade 8 Density class, the moment the class generalized, the teacher introduced the steel ship. The students wrestled with it. They had to figure out average density. Then she introduced the watermelon, then the ice cube in ethanol. 3 transfer tasks within the same lesson. By the end of the lesson, the rule had been tested across 5 different systems. The concept was no longer locked to soda cans. It had become portable. This is what we mean by transfer inside the unit. Make every concept immediately useful. Apply it as soon as it is built. Apply it again later that week. Apply it again next month when a new unit gives an opportunity. The concept becomes a tool the student keeps reaching for. The concept stops being a unit. It starts being part of how the student thinks. If you find yourself reaching the end of a unit and having to invent a transfer task because the unit never built one in, that is a signal. The unit was probably more about coverage than about concept. The concept was not yet portable when the unit ended. Next time, plan the transfer tasks early. Plan them throughout. Make transfer the rhythm of the unit, not its closing ceremony. Transfer is the hardest cognitive move. A brief note on why transfer is so hard. Cognitive scientists have studied transfer for decades. The findings are humbling. Transfer does not happen automatically. People do not, by default, apply what they learned in one situation to a different situation. The concept tends to stay glued to its original context. A student who learns about feedback loops in a biology class does not, without prompting, recognize feedback loops in their family dynamics or in their study habits. The biology stays biology. The concept does not generalize on its own. This is called transfer failure. It is the default state of human cognition. We are good at pattern recognition within a domain. We are bad at carrying patterns across domains without help. The help is what we call deliberate transfer instruction. The teacher must explicitly bring the concept into new contexts. The teacher must ask, where else do we see this? The teacher must design transfer tasks. The teacher must reward students who spot the pattern in unexpected places. This is why concept-based inquiry takes transfer so seriously. It is not enough to teach the concept. It is not enough to generalize. The teacher must design for transfer. The teacher must build transfer into the unit. Otherwise, the concept stays glued. The student learns about feedback loops but cannot use them. The student learns about revolutions but cannot recognize one forming. The student learns about theme but cannot find a theme in a song. Transfer is the hardest cognitive operation we ask of students. It is also the only one that matters for life. Everything else stays in school. Transfer leaves school with the student. This is why this phase is the final test. Because if transfer happens, the concept is real and the lesson has succeeded. If transfer does not happen, no other measure of success matters. The concept stayed in the classroom. The student moved on without it. Designed for transfer, test for transfer, reward transfer. Build a classroom in which students are constantly being asked, where does this rule apply that we have not yet considered? What you can do tomorrow. Look at the next assessment you are planning. Look at the questions on it. Now look at each question and ask yourself one thing. Can a student answer this question by recalling material from class? If the answer is yes, the question is not testing transfer. For your next assessment, design one question that requires students to apply a learned principle to a situation they have not seen in class. Just one. It does not have to be elaborate. It can be a single paragraph that describes a new situation and asks the student to apply the class generalization. If you cannot design such a question, that is itself useful information. It probably means your unit did not produce a transferable generalization. The unit covered content, but did not build a tool. Next time, work backward. Decide what transfer task you want students to be able to do. Then design the unit so that the generalization makes that transfer possible. Try this. Design one transfer question. Watch what happens when students try to answer it. You will learn more about your students' real understanding from that single question than from a whole unit of quizzes. Looking back, looking forward. In this chapter, we walked through the sixth phase of a concept-based inquiry lesson. We saw that transfer is the application of a generalization to a situation the student has not seen in class. It is the test of whether the concept is real. We met three kinds of transfer. Near transfer to a similar new case. Far transfer across domains. Action transfer into the student's own life and work. We named why most school assessments miss this. We met the GRASPS framework: goal, role, audience, situation, product, standards. We walked through 4 worked transfer tasks across 4 subjects and 4 grades. We saw that the best units transfer inside the unit, not only at the end. We touched on the cognitive science. Transfer does not happen by default. It must be designed for. The students have applied the rule. They have used the concept in a new place. The concept is real. The lesson has succeeded. But there is one more move to make, one more phase to complete. The student has done remarkable cognitive work in the last few hours. The student has formed a concept, gathered evidence, built a generalization, transferred it to new territory. What did the student notice about their own thinking? What did they discover that they did not know they would discover? What did they leave behind that they used to believe? In the next chapter, the final chapter of part 2, we move into the seventh and last phase of the lesson, the phase that is most often skipped and the one that most determines whether anything lasts.